Okay. Thank you. So, Docker for fun and profit. As Solomon Hayek said about... Okay. Better? Okay. So, as Solomon Hayek, the founder and creator of Docker project, said about Docker, it uses Linux containers and the internet won't shut up about it. So, but first, what's the difference between containers and hypervisors? So, the hypervisors are based on emulating virtual hardware. So, they emulate the complete hardware setup, they emulate BIOS, and they then start the OS. And every instance is completely separate. The size is measured, well, a couple of gigabytes at least. If you are using containers, the containers are based sharing the operating system. So every instance shares the same kernel, the kernel of the host machine, in this case the Linux kernel. And it is kind of limited that you can only run a Linux container on a Linux host. So you cannot mix operating systems. As for the hypervisor, so you can run anything on any hypervisor, almost. So there are some limits about the drivers, but in theory you can. So in theory, the container can share everything and almost nothing with the host. The only thing that the container has to or must share with the host is the kernel. One very big thing about containers is its start time. So the container can start in less than a second. Well, of course, it depends what runs in the container. If it's some Java application, it will be more than a second, always, but it's Java. And the size is measured in a couple of megabytes. And you could even share the libraries and executables between container, so the container could be limited to only applications. So the container can be more lightweight. Containers and Linux, some short history. The first containerization technology that worked with Linux kernel was OpenVZ. It was open sourced in 2005, and it was the first commercially successful. So Parallels based their business on OpenVZ as for the containers. They open sourced it, but it was out of the Linux kernel source tree, which means that if you wanted to run OpenVZ, you had to first patch the Linux kernel, then compile it, or to install it from a third-party repository. So you couldn't use the standard Linux kernel that comes with your distribution. Next, 2006 process container, which is now called C groups or control groups, were added to the kernel. 2007, Google started using C groups, and it containerized search, and from that point, the complete Googleplex went pretty much fully containerized. LXC was launched in 2008, so it was the version 0.10. And 2011, on Kernel Summit, they managed to come to an agreement, the so-called Container Unification Agreement, in which, so at the Kernel Summit, Google, Parallels, and other big interested parties came to an agreement that only one container technology will be available in the Linux kernel, which was very good for starters. The work began on container unification at kernel level, kernel API level. C groups and namespaces were agreed API, and they were included in the kernel source tree. So you could easily access them and easily compile without patching the kernel. And the agreement's most important part that only one underlying kernel technology for container will be used by everybody, as in OpenVZ, LXC, Docker, ZeroVM, and the rest of them. In 2013, the first Linux kernel that was supporting... So, can I continue? Yes. So in 2013, the first Linux kernel came out that supported out of the box. So the OpenVZ was completely functional with the kernel source tree. And it was kernel version 3.12. You didn't need to patch the kernel to compile it to run OpenVZ. So namespaces are used to isolate processes, which are then used by the container or the process inside the container. C groups are used to control the resources. There are 12 C groups and 6 namespaces in the kernel, and the containers can use all of these or any combination. As for the security, as part of the agreement from 2011, user namespaces became the container security mechanism. Unfortunately, the user namespace isn't available in a majority of the Linux distributions, and only this year started enabling them in their stock kernel that comes with the distribution. So, what is Docker? Docker is a tool that uses containers to create lightweight packages for applications with instant portability. So it uses the aforementioned kernel API that was agreed, and it builds upon it. So Docker isn't a container technology. It just uses the container technology to create its own framework, so to use it as a framework. The Docker components are the Docker client and server, Docker images, registries, and Docker containers. The Docker client communicates with the Docker daemon or server, which can be on a different machine. It can be, the Docker client can access via API remotely the Docker daemon or server, which then communicates with the lib container, which is a layer above the host OS kernel or the Linux kernel. And to run Docker, you need at least kernel version 3.8 and optionally enable memory and swap accounting. If memory and swap accounting isn't enabled when you boot the kernel, then you cannot limit the memory usage and swap usage by container. So the Docker images are basically read-only templates out of which Docker containers are instantiated. What it means that you have a base image on which you put a layer of file system. The base image is, for example, here read-only. So you put on a layer, another layer, that in which you add to the container different executables or data or code that you need. But it won't be saved until you commit that change and make it another permanent layer. I will explain that later. So these images can either be defined by a Docker file or by committing a container, so committing the changes that you made. A Docker file is a simple file that contains instructions how to build a container. And something that is also important to mention, that for example, if you have a host machine with Debian OS, so Debian version that can run Docker, you can inside Docker put, for example, CentOS. So you can mix and match the Linux distributions, and you can use any of them inside the container. The main thing is that it has to be Linux, so one Linux distribution. So there are something that's called a registry, Docker registry, which stores the images that have been built. So there is a very large community that uses Docker registry where you commit your Docker builds. There are more than 14,000 ready-to-use images. Those images can contain, for example, Redis, or Memcache, or a complete Drupal, or MySQL, or PostgreSQL. So you can just download those images, make a new layer on them, and start using them. So they are so-called trusted builds. You know where, you know the source, where they come, and you can trust those containers that they are clean. So there are two types of registries. There's a public and a private. The public is operated by Docker Inc., the creator of Docker. which was earlier called .cloud. And the private registry. So you could also register, you could also make a private registry with Docker Hub, but it's limited for a free version, or you can pay. Or you could make your own private Docker registry, which could be behind your firewall, inside your infrastructure, so nobody can access it besides you or your developer when you need to deploy something. The Docker containers are launched from images and can contain one or more running processes. And you can think about them as the building or packing aspect of Docker, and the containers are the running or execution aspect of Docker. The Docker container is an image format, a set of standard operations, and execution environment. And it captures the exact configuration of a version of an application. To upgrade the application in production, the container is usually replaced with a new version, and it takes only a couple of seconds. So for example, you have your workflow of development, so the dev version, the staging version, and the production version. They could be different versions of the Docker image, so the Docker container, and you could just swap them when you're ready with all the edits. You could just, for example, as in Git, just check out the whole container, and the update is finished. And when to use Docker? So if you need the version control for your whole system on which your app is running. So inside the container, for example, if you want to deploy your web app, inside the container, there could be a web server, a database server, and your application. So everything is inside the container, and you could apply it, you could upgrade it and make it in production as a whole. So there are no version changes. Everything is exactly as it was on your development machine. On the other hand, the Docker is really easy when you want to distribute the same machine, so the same setup for many developers to work on. You just build your system administrator builds a Docker container, push it in your, for example, private repository, and all your developers can check it out and use it. So everybody's using the same setup, and there's, well, probably there won't be a problem it works on my machine, because everybody has the same setup. You can use it to run your code on your laptop in the same environment as on the server. And yeah, I explained the phase development. And you could also combine Docker with Ansible or other configuration management system. So Ansible has its own module to control Docker. For the developers, it is build once, run anywhere. It's something that Java tried to be. So Java mainly functions like that. And configure once, run anything for the operations. Fun with Docker. So I will speak about a few ideas how to use Docker and how to have fun with it, and some workflow techniques. So you could run, for example, Skype in a Docker. As we all know, Skype accesses many files when it's running on your computer. If it should or shouldn't, well, that's for somebody else to decide currently. But you can run it in a container, so completely isolated from your operating system, from your host machine. For example, if you don't want to set up the whole multi-arch environment, you just download the Docker file, which has all the instructions how to build the Docker container in which will the Skype be started. Skype will communicate with your host machine for the sound via Pulse audio server, and you can forward the output of Skype via SSH. The same way you could, for example, make a Docker container for Dropbox, for BitTorrent syncs, or you could use it to contain your web browser. So one scenario, if you're a web developer and you want to test your application on multi-versions of Firefox or Chrome, you could easily set up a couple of containers with different versions of web browser. And it only takes a couple of seconds to start the container and to access the web browser. The Docker Streisand. So at the bottom there's a small trivia, what's a Streisand effect. There is a Streisand project which created Ansible playbooks that set up a whole server which runs IPsec, OpenSSH, OpenVPN, etc., etc. A lot of security tools. You could use a Docker file to build it, to build that server with all these services, and it's made in that way that you could run it, for example, on Amazon instance, on DigitalOcean. Every major cloud provider is officially supporting Docker. So the Google Compute Engine, the Amazon, also Microsoft Azure is supporting officially. Docker shell, which is also very interesting. So every time someone logs on your machine or some server, a new Docker instance is started. So every user is completely cut off. It has its own privacy. And this setup is interesting that if you would, for example, run before all Docker instances, every Docker instance would be behind net if it didn't have its own public IP, or you could have to run the SSH server on different ports. If you use Docker shell, they're all behind port 22, the standard SSH port. Only when the user logs in, the Docker image is started. Panamax is a very interesting project. It enables you to use a simple web interface. It combines Vagrant and CoreOS to run Docker images, and you could make a rather complex environments with Docker. So you could run multiple Docker images. For example, in a few simple clicks, you can run an instance, a Docker instance that will run Memcache, some kind of database server connected with the Apache, or for example Nginx with a different instance for PHP FPM, and run your application, your web application on it. And it is easily started. All the containers will be connected and linked and available to connect from from that setup. CoreOS is a Linux distribution which is completely set up only for running Docker, only for running containers, and it's architected that way that it uses you could use it to deploy on multiple servers. And it has a really interesting way of upgrading its software. So you have two instances of CoreOS, complete CoreOS. The one that's running is read-only. The other part is only writable. So writable. When you update, they just switch. And if something bad happens, you can just switch back. So there are a couple of workflows that you could use for working with Docker images, so Docker containers. For example, you could develop inside a single running container as you would in a single virtual machine. So you could put every service that you need inside one Docker container and work on it. So there's a base image which is based on Ubuntu 14.04. And you could add everything that you need on it and commit it to have that container which is edited by you. because every time you restart the container, all your changes are lost if you do not commit those changes, that file system level that you created. The second one is the preferred workflow, as it leverages containers and modularize. Each service that you need, you could run in a separate container and then just link them. And you need to embrace reusability of Docker files. So if you are making your own Docker files, you should write your general requirements early, commit, and name relevant checkpoint, and leave customizations last. So if you have a workflow, what do you need, what are your general needs, you should write it first, commit that Docker file, and then add on a different branch or something what you need for a different project. There's also the so-called add plus build routine. When you add the instructions, so with the docker add command, you can copy, for example, the source from your host machine inside the Docker container, and then you could just commit. And that's a new version of your application. So new version of a container that is fully running with exact versions of the services and your application. Questions? Yes? Yes?
What about the files that you upload? What's the best practice to... Let's start talking about it.
Yes?
For example, let's say you're making a Facebook and I'm uploading some image. Where do you store it? On a host, on a container, and how do you manage it?
There are several techniques for that. One technique is to use, for example, NFS, or to storage to use as external storage. So any files, any data that you don't want to commit with the Docker container, you have to store it outside the container and access it from the container. So you make it available for the services that run inside the container. The other one, which is rather popular, to use a data container. So use one container that has access to all your data on your file system, on your host file system, and to use that container as a proxy or router or something like that, in that sense, to all the other Docker containers, which will be then accessing the files.
Actually, something like a CDN?
Yes, something like that. Question? Yeah?
You were saying something about layering of the file system, the union file system.
Yes, union file system.
Idea what kind of union file system they use out?
BTRFS, so Btrfs.
And then immediately after that question is, what if you have two layers that both, for instance, need to add a user to the password file? How do they deal with that? Because if you first make one layer that does it on the password file, and then you add another layer to the password file, that works only as long as you don't take the first layer out.
Well, you can't take the first layer out because they're dependent. So you only commit the diff. Well, yes, but on the other hand, the Docker containers can share the file system. So, for example, if you create from a base image many Docker instances, they would share those file levels until that level that you add something that's different from the base image.
Exactly, but if two top layer or two sub-layers need to change the same file, you can get nasty situations if you want to exchange one of those layers or want to take it out or reuse it in another place. You get
Well,
dependency.
Yes, you have a dependency.
Problem in general. But,
Yes.
it's something that popped in my head when I saw that they use union in this.
Yes, so you mean on this part?
Yeah. It could cause
Yes, it could. It could, but yeah, the images are dependent. So every layer is dependent on the one.
in the manifest file that's declared as such.
Yes, yes. So
Not a problem.
yeah, every layer has its own hash and it's dependent. Any more questions? Yes?
I have three questions.
Yes?
Is there any maximum number of containers?
No.
No, more than 20,000 is impossible to run.
Actually, they do have a limit because all the containers share
The same resource.
same resource, and you have, for example, maximum open files.
No, that's not the problem. The problem is the memory and also the scheduler. The scheduler cannot schedule more than 20,000 containers. I have personally tested it on a machine with enough RAM.
Listen to him.
So you have your answer.
That means the answer of my question is 10,000.
Yes, less than 20,000 can be scheduled, but are not running very well. On our infrastructure, we have tested up to 2,000 on the same machine working perfectly, with around, I think, 30,000 processes running simultaneously on the same machine.
Okay.
Second question is, you said that every single user is in isolated environment.
Yes, if you use... Yep.
Is it possible to exploit that, to gain, allow user, let's say privilege escalation, some kind of, to allow user to gain access to the bottom layers?
To the host machine. So to escape from the container.
Yeah.
Well, theoretically, it is possible, and that part is still under development. So that's why you should use the user namespace, which should deal with that. On the other hand, there are some projects that deal with this kind of security issue via SE Linux. SE Linux, so security enhanced.
And third question, you said that swapping two containers,
Yeah.
the old one with the new one,
Yes.
takes about 2 seconds.
Yes.
What if you in that case? What's going to happen if you have a user log in?
Well, the user will probably yes, because when the user logs in, there are some temporary files which will be lost because the Docker container will be restarted. So everything that's not committed will be lost.
Thanks.
Yes.
What if I have a MySQL daemon running in a Docker and I upgrade with a new version of the same container? Would I lose all the data that I have, like in InnoDB or stuff like that?
If it's inside, yes.
Okay.
Yes, that's why you have to use external storage for containers, for SQL Server.
And one other question, what if I don't have AUFS in my kernel?
Then you can't use Docker. So, yeah, but almost every distribution has it. Every modern distribution has it. Yes?
To have separate kernel module for
No, no. You use the same kernel for every Docker, and yeah. And another answer for your question about security, CoreOS has that security issue kind of circumvented with a read-only file system. Yes?
So during the running of the one container, if the host system loads another kernel module, it's reflected to all other containers?
It's on kernel.
It's the same kernel. Yes?
And an extension to that, also possible that a Docker is actually loading a malicious kernel module that will give, for
No.
instance...
No, it's limited. It's limited, so you can.
So more kernel is disallowed.
Yes.
If anyone is interested about container security, I'm open to advice.
Okay, and one more question. You said, sorry?
Yes?
You said that there is a CoreOS. What's
Yes.
the advantage of it? I know it has some discovery, but what's the advantage?
The advantage of CoreOS is that it's specially built for running containers, Docker containers. So everything else is dropped off. So you could use it only for that.
Does it have any other advantages?
Yes, there are some tools to manage multiple deployments. And, well, you could easily use it with Panamax. Or you could try to install it on full metal, so bare metal, or you could run it in a Vagrant. Yeah. Any more questions? Yeah, and also, which is very interesting about the container, that they could be scaled very easily, horizontally and vertically. So you can very easily add RAM or add storage to them, and also to extract RAM, so free RAM from them. And you could easily multiply the instances that are running because you have the committed image, which you could just copy anywhere else and just run them.
Sorry,
Yes?
you said that you can subtract RAM from
Yes, easier than from the virtual machine.
It's not very easy to do that without breaking the container itself. Because
Yeah.
the out-of-memory manager will trigger if you subtract even a megabyte more than it's required for the running system.
Yes.
And it will kill whatever random process it decides.
Yes, but for example, compared to a virtual machine, a full-blown virtual machine, it's very hard to empty the RAM that it's not using and to subtract it. From the Docker, it's easier, so you can control how much RAM does the process inside the container needs and to subtract till that.
Well, you read it. There's in virtual machines there's something like a balloon timer.
Yes.
Is there some kind of technology that figures out?
Not yet. As far as I know, not yet, but they are working on it. And it should be much faster than the filling up the balloon and waiting.
So container RAM is take provision. You can't, for example, allocate virtual RAM and get it free if it's not used by the process.
If it's not used by a process, you could extract. So you could,
But before that, it's fixed for this container RAM.
yes, you could limit the amount of RAM per container.
It's not allocated. Can you use banks to?
Yes.
So it can be used by other things.
Well, as if you think,
It's a different situation. You either give a particular memory bank as exclusive to a container, or it's shared across all of the containers, and then you limit the amount of memory that all of these processes can take up from the whole
So
machine.
it both thin and thick provision.
It depends how you want to do it.
well, if you think about overcommitting your resources, that is possible to add to the containers more resource than you physically have. But when the processes inside the container start using all that resources, then you have to be very creative.
Interesting big sort file.
Yes. Any more questions? Yes?
Have you tried migrating a Docker container from one machine to another machine with Creo?
No, not yet, because they didn't. So it says on their website it's not yet stable. So they're working. I think they're working with OpenVZ because they are financed partially by Parallels, and Parallels technology is OpenVZ. So I assume that it will first start working with OpenVZ and then with the rest of the containers. Yes. More questions? Nope. Then thank you.